Hello everybody, this is Michael. In this video, we will talk about the queue space for FreeRTOS on ESP32. Okay, so from previous video, we sent one integer data through the queue, and this is a send task. This is a receive task. In the send task, we send out the data by this way. Okay, so before we send data out, is there whether there is a way to check the queue is full or not? It means the queue space, how many space we still have. Okay. So let's take a look at the menu. We have one function to check the queue space. So this is queue space available. Okay, so it will return the number of the free spaces that available in the queue. Okay, so how we use this function? Okay, so we copy all of this one. Open our previous queue. Open our previous code. Here, we put it here. For this function, the input parameter is the queue handle. So we just copy this one. This is our queue handle. We paste it here, and it will return the number of the spaces. So I define the space number equal to it. Okay, here we print out the queue spaces. Space number equal to this value. So this is print out the space is here, and this is the send out task. Let's remove the receive task function. We don't receive any data. We don't receive any data here. It just do the delay for 1 second. So if we don't receive any data after, because our queue designed as 5 items, the length is 5. So we send 5 times data into the queue. The queue should be full. Okay. So when the queue is full, the space number should be 0. Okay. When the space number is 0, we should see this output information. Can't send. Okay. We should see the can't send output information. So we save it, and we open our command line compile environment. Okay, so we compile it, idf build pe build to compile it. Just a moment. Okay, you will see we get some error here. Is the compiler is unknown. This compiler is unknown. Okay, the reason is we didn't locate our source code folder, so we need to go back into our source code folder, go into my code, go into hello world, and then we do the IDF builder again. Okay, we do the IDF builder again. It has to be in the current source code folder. We are based on the hello world folder to do the coding. Okay, now it's successfully begin to compile. Okay, you take a moment. So if we just change the application code, we can just use IDF PE app to compile it. Okay, take a moment. Okay, you will see here we have some warning. Warning unused J and warning unused variable X status and warning about this because we just remove this code for testing. Here, this variable didn't use it, so we can also remove it. Remove it to take a look. This kind of warning, sometimes we need to pay attention, and sometimes we can ignore it. Okay, but here we just remove the define and to check it. Okay, generating the link file. Link EL file. Okay, so no any warning here. And here we begin to refresh it. Okay, fresh. Okay, we open our monitor. Okay, 5, 4, 3, 2, 1, 0. Okay, so we can stop the monitor right now. We can analyze the output information. Okay, so the first thing is the queue create successfully, and the space number is 5. Means we didn't write any data into the queue, and send it done means when it send it done means we write one data into the queue, and the space number will be deducted by 1, will be 4. Similarly, here after another send done is 3, is 2, is 1, is 0. When it is 0 means the queue is full. So we cannot send any data. We can't send data. So how about if we get some data out? Okay. If we get some data out to see the space number, what will happen? We open this code. We open this code, and we also open this code. Okay, so it means we send one data and then we read it out. So let's see what will happen about the space number. Okay, what will happen about the space number. Okay, we still need to build it. This building generating link file. Link ELF file. Okay, finish. And then refresh it. Okay, so we open our monitor. Okay, you will see it's output some information already. Let's stop the monitor right now. So you will see the first things is space number is always 5, 5, 5, 5, 5, 5. So which means we write one data into the queue and read it out immediately. Is here. Receive j equal to 0, receive j equal to 1, receive j equal to 2, receive j equal to 3. We write it data and read it out immediately. So the space number, it will always 5, 5, 5, 5. Okay? Okay. So this is the queue space a variable, which is for the send data, for the queue send data. So is it a function for the read data, for the queue receive data? So we can check how many data in the queue and how many data is available for us to read it out. So let's take a look at the manual, reference manual. We have another function for the reading action. Okay, let's take a look at it here. Okay, so this is the queue message waiting. It will return the number of the items that are currently held in the queue. Okay, so it tells us how many numbers, how many data in the queue. So how we use this function? We copy this function, and we put it into the receive task. Copy it, and here we define one data item equal to this one. And for this function, the input parameter is the queue handle, which is here. This is the queue handle. We put it here. Okay. So here we still output the date item. The date item. This is the date item. Put it here. So this means how many data in the queue, and we still remove this read action. We remove it. So the result will be like this. The date item will increase from 0 to 5 because we didn't read it out. Every time the send action, the queue send to back function running for one time, it will send one data in the queue. So this one will increase by 1. Okay, let's take a look how it works, how the output information. We build it. Okay, so this one is for the this queue message waiting is for the reading. Okay, this space variable is for the writing. Okay, here has some error. Let's take a look. The queue handle on decline. Okay, let's check it. Because we remove this one, so we need to open this one. This queue handle need to use for the queue message waiting. We save it to build it again. Generate the link file. Link ELF file. Okay, finish compile and refresh it. Now it's freshened. We open our monitor. Okay, we stop it. So you will see the iData item continuously print it out, and it didn't stop because we remove the delay function here. So we still open it. It means every 1 second we print out for one time. Okay. So we needed to build it and compile it again. Okay, IDF PE build. Generating the link file. Link ELF file. Generating bin. Okay, refresh it. We open our monitor. We open our monitor. Okay, you will see it has output some information. Let's take a look. Let's stop the monitor to check the information. Here, the queue created successfully, and the variable space is 5. Sent done. The item is 1. Okay, it means have 1 data in the queue, and here the data item is 2. Has 2 data in the queue, and 3 variable space. This data changed to 3, and they have 2 variable space. This is 4. This is 1. space number is 1. To here, the data item is already 5, and the space number is already 0, which means the queue is full and cannot send data anymore. So cannot send data, can't send data, okay? Cannot send data. The data item is 5, space number is 0, okay? So this is a pair of functions. This for the write and read. This queue space available function is for the write task, for the send task. This is the queued message waiting function is for the read task, is for receive task. Okay. So this is for the queue space. This video. This is this video. I'm Michael, and see you next time.